Hi, everybody. Last video, I spoke about sampling proportions, and this one I'm going to talk about sampling for means. Now, this course will mainly focus on sampling distributions for either proportions, which is our p, or for means, which is our mu. So let's take a look at this normal model that we have up here in the front. And it's telling us that the mean and median are both 16. If we wanted to select a sample of, let's say, 5, here it is animated. It's taking a sample of 5, and then on the bottom here, it takes the average of these 5 items and places it here. And this below here, the third distribution, this will be our sampling, our ing. Now, if I do this again, it's going to take a different sample of 5 and take the average of that and place it below here. And I can repeat this many, many times. And every time I will have a different outcome, a different mean, a different average. So as I do this over and over again, in the blue is my sampling distribution that is being created. So if we did this, you can see that every time the mean is different. What does it look like if we do this many, many times, such as 10,000 times? Well, we find that if you look over here, our mean of the sampling distribution is the same as the mean of our population distribution. Now, in this case, our sample size is 5. Let's do this again and see what happens when we have a bigger sample size. So I'm going to change the sample size of 5 to a sample size of, let's say, 25, and I'll repeat the same procedure. So we're going to take a sample of 25 this time, and then out of these 25, we are going to find the average, and that will be placed in the third distribution here below. I will do it again, and you can see that as the sample is being collected, it's going to take the average of that sample and place it in the third distribution below. So as I'm doing this, go ahead and look and observe to see what is going on. It just so happens the first two were the same, but let's see our third one. Now, if we did this 10,000 times, we can see that our distribution resembles the population distribution. It's normal-like looking, but if you notice, the standard deviation is much smaller. Now, as we repeat this, if I did this with a smaller sample size, such as 2, and I animated it, what would happen if I did this 10,000 times with a sample size of 2? Then our standard deviation is much larger than my previous sample size that was much bigger. So the bigger the sample size, the smaller the standard deviation becomes. So let's change this 2 again to 25 so you can see that happening. There we go.